Hey everyone, I'm Mike. Welcome to another video here on the Vital Dose. So for those who do not know me, I am a doctor of physical therapy and certified exercise physiologist, among other things. I've been in the fitness, coaching, wellness realm for 13 plus years and have become fed up with the lack of quality information regarding dietetics, micronutrients, and performance, and so forth. My intent has always been to provide people with just higher tiers of knowledge and education using the science we have to the best of my ability. So today we are diving into vitamin C. And what if I told you that most people are using vitamin C completely wrong? From megadosing myths to fizzy tablets in cold season, vitamin C is one of the most misunderstood nutrients in your supplement stack. So what does the science actually say? So vitamin C is also known as ascorbic acid, and we're going to go in to figure out what it actually does inside your cells, how it affects performance, immunity, and recovery, real optimal dosing versus the RDA, and whether or not there's a difference, and whether or not you're just making really expensive pee. We're going to generate like a sample food and supplement plan to address daily intake. We'll look at some blood work parameters to assess for deficiency, albeit a little more rare in modern society, along with other clinical manifestations and how it impacts other organ systems also when in deficiency or at optimal levels. And please note, while I may have small amounts of anecdote here and there, there's a complete list of full peer-reviewed citations in the description of this video for you to see where my information comes from. So if you want to train hard, biohack smarter, or just out-recover the competition, you're in the right place. So let's get into our next section. What exactly is vitamin C? Vitamin C, or L-ascorbic acid, is a 6-carbon, water-soluble molecule essential for life. It acts as a powerful reducing agent, meaning it gives up electrons to fuel biochemical reactions, aka it's an electron donor. And sure enough, almost every other mammal can produce it internally from glucose except for us. And this is due to a mutation in the GULO gene. Humans lost their ability to synthesize vitamin C innately. So every milligram we get has to come from an exogenous food source, aka our diet. And back in the 1700s, sailors who didn't get enough vitamin C developed scurvy, as I'm sure you recall, which is also known as a deadly breakdown of collagen, connective tissue, and immune resilience. Lemons literally save their lives, albeit citrus fruits are actually lower on the totem pole for vitamin C intake. More on that later. So we've moved past scurvy, and today, vitamin C is a staple in performance stacks, IV drips, immunity protocols, and so much more. And it turns out it's a core molecule for elite performance, cell repair, and neurological sharpness. On an aside, vitamin C structurally as a molecule is similar in nature to glucose. It exists mostly in the ascorbate ion, and it's transported into cells via the SVCT1 and SVCT2 sodium-dependent transporters that contain vitamin C within the immune cells, the brain, and the adrenal glands. So now we're going to move into what vitamin C actually does within the body. And while this isn't necessarily a free radical deep dive, I want to touch on them a little bit for understanding. Your mitochondria are the powerhouses of your cells. Thank you, 5th grade biology. But during ATP production, your mitochondria also release reactive oxygen species, also known as ROS, as byproducts of said reactions. These free radicals are necessary for cell signaling, but in excess, they cause damage to DNA, proteins, and lipids, especially under stress, intense exercise, or inflammation. So excessive or uncontrolled ROS, or reactive oxygen species, however, due to mitochondrial dysfunction, toxin exposure, chronic inflammation, or poor antioxidant defenses, can lead to a series of ill-advised or ill-wanted effects within the body. We see this manifest as damage to DNA, promoting all sorts of mutations during transcription and translation. We also see this alteration in lipid membranes affecting cell signaling in general, and disruption of proteins, including enzymes and structural components. The oxidative damage that occurs, at least in higher quantities and amounts, is linked to the initiation and progression of many chronic diseases that you're probably familiar with, including the following big ones: cancer, CVD or cardiovascular disease, neurodegenerative diseases like Parkinson's, various autoimmune conditions like Hashimoto's, and metabolic syndrome. Regarding free radicals, I'm going to give you 3 of the worst offenders, but I'm not going to go into much detail in this video on what precisely they are. Superoxide anions are the first, hydroxyl radicals are the second, and peroxynitrites are the third. So just know those are kind of the big hitters when it comes to free radicals within the body. More on that in another video. So these molecules are like biochemical wrecking balls, and vitamin C neutralizes them by donating the electrons, like we kind of talked about above. Essentially, it diffuses them before they can kind of damage those cell structures we talked about, inclusive of DNA. And this helps recovery, helps preserve mitochondrial function, protein integrity, and so much more. Moving into the brain, vitamin C is highly concentrated in the brain itself, and it's not just hanging out there, it's working. Primary roles include vitamin C driving the conversion of dopamine into norepinephrine via dopamine beta hydroxylase as a cofactor, sharpening your focus, amplifying drive, and priming you for action. It also assists with serotonin synthesis via the tryptophan metabolism, supports acetylcholine synthesis and protection, critical for memory and learning. And also, vitamin C supports carnitine production, which boosts brain and muscular energy metabolism, aiding fat oxidation and endurance. But for the brain specifically, we're concerned about vitamin C in regards to its neuroprotective effects with carnitine and its ability to help supply neuronal energy demands, which are very high in the brain. Briefly, all of these neurotransmitters and molecules, in essence, dopamine is your brain's motivational currency, influencing pleasure, anticipation, and behavioral reinforcement. Norepinephrine is kind of like your go mode neurotransmitter. Serotonin is your emotional thermostat, helping to stabilize mood, optimism, and resilience. Acetylcholine is your brain's command center for memory, learning, and sharp mental processing. And lastly, carnitine is your fat burning shuttle in addition to playing the neuroprotective role we talked about, all of which rely on vitamin C heavily to remain in favorable function. Now we're going to move into natural dietary sources of vitamin C, cooking stability, and flavonoid synergy. Vitamin C is not only a critical human nutrient, but also a key stress response molecule in the plant kingdom. In plants, it plays a central role in redox regulation, aka protection against oxidative damage, just like it does in humans. In plants, they're more so concerned with environmental stressors like UV radiation, temperature fluctuations, and microbial pathogens. When vitamin C and plant-rich materials are consumed by humans, they provide us with externally sourced, evolutionarily conserved molecules that support antioxidant defense and all the other wonderful things we've talked about so far, especially under conditions of physiological stress like intense training, injury, or inflammatory load. So let's move into some of the primary food sources of vitamin C. While citrus fruits are often associated with vitamin C, they are far from the richest source, believe it or not. The most concentrated forms are typically found within wild or minimally cultivated plants with high environmental stress exposure because they have to be incredibly resilient to their environment. Additionally, several animal-derived food sources we'll talk about in organ meats, shellfish, and so forth offer modest contributions. So I have a cool little chart here. I'll try to put up parts and pieces of it as we go through. The chart is listed and ordered in 100-gram edible portions of whatever food, plant, meat, or nutrient that we're talking about. So first and foremost, what I could find anyways, per 100 grams of edible portion, the highest vitamin C content food is the kakadu plum native to Australia. So if you don't have access to that, don't worry, we have plenty of other options. Next would be the camu berry, which you'll see often featured in powders and supplements. Again, the whole food, raw food is always better. Then we have some cherries, rose hips, black currants, guava, and kiwi might be two more mainstream fruits you can get your hands on depending on where you're located within the world. Next, strawberries, oranges, other citrus, pineapple, grapefruit, and so forth down the line. For raw vegetables, we find the red bell pepper to have 120 to 190 milligrams or so of vitamin C per 100 gram serving, especially when consumed raw. This is a great place to start as you can snack on peppers throughout the day. Then we have kale, broccoli, Brussels sprouts, and so forth. Moving into some of the animal-based sources, you'll see beef liver and lamb liver come in number 1 and number 2 for edible food sources that are meat-based. However, the overall content is much lower to the plant-derived sources of vitamin C. Organ meats and shellfish do provide usable vitamin C when consumed raw or minimally processed, but they're highly sensitive to cooking, which means when you start to heat them, we lose vitamin C stability, and we'll talk more about this soon. The leafy greens you might do better with salads, smoothies, or lightly cooked or steamed meals. And lastly, citrus peels are the aspects of the fruit that are particularly rich in flavonoids, which aid vitamin C absorption and vascular tone, and we'll get into what some of these flavonoids are very shortly. So now we're going to move into cooking stability in terms of nutrient loss and preservation of vitamin C within prepared foods. So vitamin C is both water-soluble and thermolabile, meaning it degrades rapidly under conditions of heat and prolonged exposure to water, oxygen, light, or air. Cooking method directly influences how much of the original ascorbic acid remains bioactive by the time you actually eat the food. And we'll get into this now. So I have another little chart we'll put up here on the screen for you guys. Keep things real simple. If you boil your foods, we're going to see vitamin C dissipate within 2 pathways. It's going to leach into the water because, again, remember we said it's water soluble, and it's going to break down with the high heat. Steaming will kind of be similar in nature. However, there's a little less water exposure, so you're going to have a little more vitamin C left over. Stir fry, microwaving, things like that, they're a little bit less aggressive. And lastly, eating the foods raw or minimally processed at all will probably give you the closest you can get to full ascorbic acid profile. There is a little bit of literature out there, I didn't really get a chance to look into it, that I've read and seen that pre-cutting your produce and leaving it pre-cut, a lot of these flavonoids and minerals start to dissipate too with time versus letting the food ripen by itself. And of course, the more the food ripens, the more these vitamins and minerals dissipate too, especially vitamin C. So again, I don't have anything cited on that down below. This is just something I've seen across different places, but it might be something worth looking into for down the road. And for individuals with elevated recovery demands, athletes or people recovering from illness or surgery that want to be really diligent about their intake, then raw foods are probably your best bet, at least in terms of produce-based foods. So earlier we referenced flavonoids, polyphenols, and cofactors for vitamin C absorption. So we're going to kind of get into that now. I'll try to keep it a little simple, and I do have a chart for you too. So in general, vitamin C, when it occurs in nature in whole foods, often coexists with things called flavonoids, which are a diverse class of plant-derived polyphenols. These compounds contribute to cell signaling, oxidative stress reduction, and absorption of vitamin C itself into our bodies. They almost act like they're cofactors of vitamin C, is one way I guess you can put it. In essence, they help the body absorb vitamin C and help it to do its job within the body most effectively versus a pure form through a supplement. More on that later. Co-ingestion of vitamin C with flavonoid-rich foods has been shown to improve plasma retention of vitamin C, delay oxidative breakdown of vitamin C within our bodies, and enhance the utilization of vitamin C during inflammation and stress. And down here I have a little chart. I'm not really going to read through this, but you'll see some of the different food sources that offer different flavonoids themselves, all of which play an individual role. A little too complicated for this video. So more or less, pick your citrus, your apples, your black currants, more citrus, and maybe some kale or spinach, and you'll kind of have your bases covered as a good place to start, at least in terms of getting all the flavonoids you can possibly get. They also play many other roles within the body, but again, that's for a different video. So let's wrap this section up with some practical applications for vitamin C intake through your foods. So combining flavonoid-rich produce such as berries, citrus, and leafy greens with vitamin C-rich foods is going to improve post-training absorption, or really absorption any time of the day. Using raw or lightly cooked forms of vegetable and produce would be best. And when consuming supplemental vitamin C, consider pairing it with whole food sources, again, to kind of get those flavonoids in you to help with that digestion and actual plasma retention of vitamin C when it's in your body. Now for the part that everyone came for, supplemental forms of vitamin C absorption and timing strategies. We'll talk about performance, we'll talk about types of supplements, we'll talk about a whole bunch of stuff in this section for vitamin C and some of the misconceptions that exist. While dietary intake is probably the #1 foundational approach I would have with vitamin C intake, supplementation may become essential in conditions where the physiological demand exceeds the baseline nutrient supply. Basically, it's a fancy way of saying you can't eat quite enough of the foods you're supposed to get as much vitamin C as you might actually need in specific situations. So what are some of these specific situations that you might need a little more vitamin C in your diet? More on dosing later. High intensity or high volume athletic training, especially resistance training and long distance running. Acute illness or immune activation, post-operative recovery, I would argue, is probably the #1 reason, second to training, and chronic inflammatory or environmental oxidative stress. If you work in a place with lots of chemicals and environmental toxins, construction, things like that, you might just need a higher level of vitamin C to help decrease and offset this oxidative burden. So in all these contexts, both formulation and timing of vitamin C definitely determine the efficacy of supplementation. And no, not all vitamin C supplements are made the same, and understanding absorption, saturation, and delivery kinetics is critical for maximizing your benefit of vitamin C supplementation if that's the route you choose to go. So let's get into some of the forms of supplemental vitamin C. First, we'll start with ascorbic acid in the unbuffered form. So this is the pure water-soluble form of vitamin C. Molecularly, it's identical to the same vitamin C found in the whole foods we talked about above. Usually, though, it does not have the other flavonoids, so keep that in mind for absorption's sake. When taken orally, it's rapidly absorbed into the upper intestine. However, for some, it can cause gastrointestinal irritation in dosages above 1,000 milligrams due to its low pH, aka acid and unbuffered, albeit it's pretty rare. Best for general immune support in smaller doses, short-term illness support. My experience, only folks with gastritis or IBS really seem to exhibit any type of issue with this, but perhaps other people may. Next in line would be buffered ascorbates. Basically, your ascorbate acid would be bound to a mineral salt like sodium, magnesium, calcium, which in turn would reduce the pH, make it more alkaline. This way it's less acidic. So you're less likely to have that GI upset. It's a little bit gentler on the stomach, slower absorption profile overall as well. Best for athletes or individuals with higher dosing requirements, as again, it's less likely to give you the GI upset. Third, and arguably best, would be liposomal vitamin C if possible. Vitamin C encapsulated in phospholipid-based liposomes, typically lecithin, absorbed via the lymphatic pathway, bypasses saturation limits in the GI tract because we're avoiding the intestine altogether. So we're going to see plasma levels 2 to 4 times higher than standard oral formulations and no GI distress. This might be best for those like post-surgical patients with really, really high dosage requirements, neuroprotective applications, high recovery athletes, things like that, and arguably the best form of vitamin C to supplement with orally. However, again, with the other two, I've never really encountered anyone with issues with these, so keep that in mind for what it's worth. A little bit of anecdote. Then we have ester C, which is a trademark, or calcium ascorbate and metabolites. Not as common, I won't go into it too much. So it contains calcium ascorbate and naturally occurring metabolites that come along with this. A little slower absorption curve, maybe better tolerate in higher doses. I've never even seen this or looked into it on the market personally, but I'm sure someone out there has it and is taking it. And lastly, it's also, our vitamin C is also put into folks intravenously. Least common, so it's administered via infusion, of course, bypassing all gastrointestinal limits, and used clinically for sepsis, viral infection, burn recovery, and so forth. And that's all we're going to cover for those. So liposomal vitamin C and buffered ascorbate might be the best two to reach for oral supplementation if you're purchasing online or purchasing at a local supplement store. So now we'll shift into absorption kinetics and plasma saturation of vitamin C. Basically, we'll go into whether or not smaller or larger bolus dosings are more ideal and how deficiency declines with larger bolus dosings, hint, hint. So what we see is an oral dose of roughly 200 milligrams, give or take, or less. We get about 70 to 90% of that actually absorbed into plasma, which is pretty good if you think about it. If we move up to 500 to 1,000 milligrams of oral supplementation all at once, we see maybe 50 to 70% of that actually absorbed, which again, could be decent. If you take in 1,000 milligrams, maybe you only get 500 out of that. Again, combined with whole foods, flavonoids, and all that fun stuff, you might actually see a little bit more. I don't have hard numbers on that, and I couldn't find too much in the research, but what I did find is pure supplementation of like our buffered or unbuffered or liposomal forms. This is kind of what we see enter plasma. And then lastly, larger bolus dosing of 2,000 milligrams or greater, we get maybe 30%, sometimes 40%, depending on the study. The remainder is excreted in urine. So that's something to think about in terms of dosing. You might find split dosing throughout the day is a little bit better or a little bit more effective in terms of absorption into the body. And now we'll head into timing considerations and dosing strategy in terms of exercise. So a hot topic right now is whether or not high dose vitamin C pre-training, pre-resistance training, I should be more specific, blunts hypertrophy outcomes, aka makes you build less muscle mass. So what I found, I looked at a whole bunch of studies and systematic reviews and whatnot. The general gist was, well, I won't ruin it. So let's get into one study here. So Clifford et al., he did a systematic review. He concluded that vitamin C and a little bit of vitamin E supplementation does not blunt exercise-induced adaptations, irregardless of age. So they looked at all sorts of folks. They looked at all sorts of dosages from 200 to 1,000 milligrams per day across a systematic review. And vitamin E was included in a good chunk of them at about 400 IU per day. So what we're looking at is like these antioxidant-based minerals, whether or not they decrease your body's ability to, I guess, result in hypertrophy following resistance training. What we found here with this systematic review is we did see cellular signaling for like antioxidant enzyme upregulation and reduced mitochondrial biogenesis-based signaling, things like that were reduced, but actual outcomes of muscle gain and muscle growth were not reduced. So the pathways that are responsible for producing training adaptation, even though they were slightly downregulated, we still didn't see that, like in terms of the placebo group to the main group, affect actual strength or muscle gain outcomes. So, and there's no direct measurement of how much blunting occurred. So it's kind of hard to say. No one's really measured that I could find. I had another study here, Paulson et al. In 2014. He looked at 1,000 milligrams of vitamin C and 235 milligrams of vitamin E taken before training for 10 weeks. No significant difference again in muscle strength or mass gains, but still saw the blunted cell signaling like we did in the systematic review there with Clifford. And lastly, Bjornson et al. In 2016, this one's kind of the outlier. So he found some evidence of blunted muscle hypertrophy or lesser outcomes in the test group versus the placebo group. But he looked at older men, 60 to 81 age range, healthy, and not strength trained for the last 6 months prior. So he had one group with the antioxidants, one group without it. So 1,000 milligrams of vitamin C and 235 milligrams of vitamin E. Both groups, placebo and test group, did a 12-week full body program, 3 days weekly. They used DEXA ultrasound 1RM testing, and I did like this study because it was really, really well done. Again, what they found was the group that had the antioxidants had less lean muscle mass gain, less thickness in muscle, and no serious differences in strength. But he did find tangible, I guess, result, we'll call it, that said, hey, we had a decrease in outcome of hypertrophy when preloading training with 1,000 milligrams of vitamin C and some vitamin E. So this is kind of the only one I could find that I really liked that supported the notion that there might be some decrease in actual hypertrophy. But again, the age range was 60 to 81. So younger, more athletic populations, there might not be as much of a difference. So here's a little chart that kind of sums up everything I learned from those studies. I did skim through some other stuff I didn't cite, and I kind of found the same stuff, but these particular studies really stuck out to me, so I use these selectively. So bottom line or big takeaway here, yes, antioxidants like vitamin C can blunt hypertrophy-related signaling. However, that doesn't necessarily translate to you will automatically lose X amount of gains or decrease in X amount of hypertrophy from your training. It might be more subtle for younger athletic populations. For your enhanced lifters with the use of PEDs, you are likely just fine. For your average gym goer, the practical impact, again, is probably tiny and small. However, if you're a high-level competitive athlete in the resistance training or bodybuilding world or long-distance world, that little tiny bit might just be enough to decide between first and second place. The jury is still out, so I'll leave that one up to you. So now we're going to move into actual dosing with hard numbers and the RDA. The RDA is listed as below here in this chart. You'll see that breastfeeding women have the highest kind of dictated requirement by the government standards here anyways, but no one exceeds 120 milligrams per day for their RDA. So the real question is there a benefit to higher dosage supplementation of vitamin C, maybe nearing anywhere from 1,000 to 3,000 milligrams daily, which seem to be the hot numbers kind of put out in the media and put out on social media and places like that. So is there any science that says, yes, there's benefit to these higher dosages? Before we get there, my takeaway from everything I read and discovered was for non-active general population, healthy people, hard to be that healthy if you're not active, but nonetheless, I digress. What we see is the RDA is likely sufficient or maybe just a tiny bit insufficient, but you don't really need maybe an excess of 200 to 300 milligrams daily, all said and done, if you're one of those individuals. So now we'll move into some of the higher dosing studies I looked at, and I have another chart for you that kind of sums them up. So I'll go through these a little bit quickly. The gist is that supplementation of greater than 1,000 to about 2,000 milligrams of vitamin C per day only showed benefit. I could find nothing that said it was deleterious or that there was a cutoff dose around 2,000 that was inherently bad. Or inherently bad at 3,000. There were some folks that were outliers with stomach issues and such, but that seemed to be very minimal. So what I found was supplementation of 1,000 to 2,000 milligrams across most of these studies I looked at here showed like a decrease in all of the oxidative states in individuals and some of the oxidative markers that we'll talk about down in the blood work section. It showed like anti-inflammatory effects, reduction of the common cold symptoms, other immune-based functions were supported or improved, or markers of the immune system were supported and improved, or decreased infection risk in post-op patients was another big one I liked too. Better endothelial function, reduced blood pressure, things along those lines. So there might be some cardiovascular benefits too, exceeding 1,000 milligrams. This is again combined through food and supplementation, everything else. So nothing deleterious that I could find saying, oh, this is inherently harmful. And again, we know vitamin C is water soluble and it is excreted in your urine in larger doses and quantities. That doesn't mean you should go take 10,000 milligrams for a blanket to be safe, but seemingly the not to exceed 2,000 to 3,000 milligram dosages are tolerated well with no deleterious effects. So here's my own little dubious set of extrapolations for what I found in the literature pertaining to dosages. Most of this we already covered. Your general health people that maybe do some light walking, feel as though they eat a well-rounded diet and are in relatively good shape on their blood work and whatnot. 200 to 400 milligrams may be supplemented or taken in with meals through ascorbic acid and food is probably more than enough. Performance and training, if you're into the gym a little bit, nothing too crazy, maybe 500 to 1,000 milligrams post-training if you want to be real technical about it. Buffered or liposomal are fine. And the one thing I didn't mention above, side note, is that during training, I think the cutoff threshold was 2 to 3 hours pre-training. I think I saw that in one study, don't quote me on which one, but more or less if you took your vitamin C supplementation like 3 hours pre-training, it didn't have as staggering of an effect as it did like taking it 30 to 40 minutes before, but don't quote me on that. I think I read that in one of the studies briefly. And then moving back to where we were here, injury and surgical recovery, 1,000, 2,000 milligrams in split dosing, illness and infection, 1,000 to 3,000 split dosing. And if you're an enhanced athlete, or if your ROS is very high, 2,000 to 3,000 milligrams daily post-exercise, broken up through buffered or liposomal forms with flavonoids if able, so with whole foods, would probably be the recommendation with no deleterious effect at that 3,000 milligram mark. So athletes and resistance trained people, again, they're going to have the higher stress response, and long distance runners and things like that too. Higher stress response, therefore higher ROS burden, therefore a little bit of higher supplementation or intake of general vitamin C seems to be the way to go. And again, if you're an enhanced athlete and you're using anabolics, exogenous growth hormone, things like that, your metabolic demands are even higher, and you'll find that the free radical burden inside of you is even higher as well. So the dosing of 2,000 to 3,000 milligrams might be more ideal for you. So now we're going to move into building your intake through food and supplementation. We're going to start to put together sample dietary plans or daily plans you can follow to incorporate supplements and food and timing and all of this to kind of get the most absorption we possibly can. We talked about, again, with the whole foods, we get the flavonoids and polyphenols that enhance the vitamin C absorption and recycling. We also talked about how a lot of those whole foods have very small milligram dosages of vitamin C. So if you're someone that needs 3,000 milligrams of vitamin C per day based on activity requirement or reactive oxygen species burden, you might find it hard to eat, 50, 60 lemons to get all of that in. So we'll kind of talk about filling up the gaps here with supplements, and we'll go through a little sample couple charts here with whole foods and supplement combo. So I'm not really going to talk through these. I'll just put these up on the screen so you can see. So that's kind of what our food might look like for the day. And I try to use foods that maybe most folks around the world have access to unless you're in Australia. And then this is what the supplementation combo per se would look like. And then you can kind of extrapolate from there. So we put like a packet in to start here with the vitamin C liposomal, and then we ate some other citrus fruits, berries, things like that. So you can see roughly what our totals are like on the screen here. And I got one more we'll kind of do. This is vitamin C synergizing with other minerals, I guess we'll call them, for that reactive oxygen species decrease. We'll call this a little bonus. I'm not going to go into detail on what a lot of these things are. You'll have to wait for future videos, like when I cover glutathione and NAC, quercetin, zinc, things like that. But I just wanted to kind of show you what vitamin C pairs well with in terms of antioxidant reduction and organ health, which we'll cover down a little bit below in more of the clinical stuff. So now we'll move into our final section regarding clinical markers, deficiency, and organ system involvement with vitamin C. So for deficiency, albeit it's fairly uncommon in developed countries, I'd argue the noticeable or tangible effects of vitamin C deficiency would manifest as the first line in the chart that I'm going to show you momentarily. You could definitely argue that there are more likely to be more than one mineral deficiency present, but for example's sake, we'll cover kind of just what you'd see with vitamin C strictly, which in the body never is really a thing, as in you can't just isolate one thing in the body and say, oh, this is the problem, but nonetheless. So we're also going to look into blood markers and how to loosely check for deficiency too in that domain, or something to think about. So here's the little chart for general population. You might see fatigue, low mood, things like that, due to that dopamine depletion or mitochondrial dysfunction we talked about, maybe just having a higher burden of oxidative stress as well, easily bruising, gum, or bleeding due to capillary fragility, frequent illness, slow wound healing, and poor iron absorption are things to look at. Again, there's a ton of places that these, I guess, clinical manifestations can come from, but these are things you could look into and say, hey, maybe vitamin C is playing a role. In the athletic population, I'll put this up there too, increased soreness or delayed recovery, unchecked oxidative stress yet again. If you're not sensing a trend yet with the oxidative stress, I don't know how else to help you. Joint or tendon pain, inadequate collagen cross-linking, low immunity during overreaching or like really full sending it on training. And then lastly, CNS fatigue or just poor stress tolerance. So again, there's probably many factors that would be underlying for these, but could look at vitamin C and say, hey, maybe it's playing a role. So here's some relevant lab markers. You can directly measure plasma ascorbic acid, which is kind of cool. So that's like a direct vitamin C kind of status, if you will. Those are the values and numbers. You might see CRP or high sensitivity C-reactive protein, which is an inflammatory marker. Kind of general. I'm not going to get into blood markers in this video, but you can do some research on your own if you like. Elevated, again, might just mean, or out of the reference range even, might just mean potential oxidative burden. And I will not talk about norms here either. OHDG or MDA, another kind of oxidative damage status for DNA. Ferritin or serum iron we mentioned above, and then lastly, neutrophil function if available, wherever you get your labs done, to see. I would argue again, vitamin C deficiency is more functional than absolute in athletes. Even if you're just taking in the RDA, chances are you're gonna be okay. If you're a very high intense competitor athlete, you might notice some of that fatigue or high oxidative load, sleep deprivation, things like that. So you want to find yourself at the higher end of that 1,000 to 2,000 milligrams if you're a high performer. So just keep that in mind. And now we'll kind of move into organ systems and talk a little bit about that. So vitamin C actually does have a pretty profound role throughout the body in different organ systems, of which we've covered some, especially the brain. Male fertility, we see vitamin C, due to its antioxidant status, more or less, have that improved sperm quality by reducing, yet again, oxidative stress. We have studies that kind of looked at higher sperm count, better motility, and less DNA fragmentation. Citations are below, with the use of vitamin C supplementation. Off the top of my head, I want to say these dosages were higher end, like 1,000, 2,000 milligrams daily as well. Female fertility, we don't quite know 100% why, but we also see, again, that ovarian tissue protection from decrease in oxidative stress and optimizing progesterone, which is incredibly important for female fertility. Vitamin C plays a very important role for adrenal and thyroid function in regards to protecting thyroid tissue, again, that oxidative burden. And we'll also see this manifest potentially in Hashimoto's thyroiditis when the immune system kind of targets itself in that regard. So that's something to take a look at too, just to kind of see where your vitamin C levels are at. Other organ systems we'll kind of briefly take a look at: the liver. So if you ever heard of non-alcoholic fatty liver disease, a lot of bodybuilders will succumb to this. We see an improvement or decreased risk of this due to lowering that oxidative burden, as well, and improved insulin sensitivity with intake of vitamin C around that 1,000, 2,000 milligram daily range, albeit minimal, but enough to mention anyways. Lungs, reducing airway inflammation. So there's a lot of literature out there regarding asthma and COPD based pathology, and vitamin C supplementation to kind of help offset or augment that a little bit. Kidneys, again, we know neuroprotectiveness of vitamin C, but also nephroprotectiveness of vitamin C in higher doses. Super high doses. I want to say it was 3,000 to 4,000 milligrams plus, maybe even more, could potentially cause issues and nephropathy. I didn't really find too much out there that said this was sound, and most of these people were ill to begin with. So again, typically you just secrete it unless you're like mega dosing 10,000 plus milligrams. That might be something to think about not doing, but nonetheless, chances are we're kidney safe here with 1,000, 2,000 milligrams, and also nephroprotective, which is kind of cool too. Lastly, the adrenal glands, which you talked about in the very beginning, they store a little bit more vitamin C than other parts of the body, inclusive of the brain. So we see this for cortisol synthesis and stress resilience, or the role of the adrenals for vitamin C storage and use. So here's a little quick summary chart to kind of go over all the organ system stuff we just talked about. This way you can have it in writing. And this concludes our vitamin C deep dive. I just want to say thank you so much for sticking around. I'm going to do my best to timestamp this video as well. They might not be super specific, but they'll be enough to say so. And down below, again, in the description, you can find an entire citation list of everything that I used, with a little bit of anecdote sprinkled in here or there. If you found this video helpful, please share it with somebody. Like, comment, subscribe for the good old-fashioned algorithm. And stay tuned. I think my next video is going to be on magnesium. So that's going to take some time, and we'll get into that. And I'm always open to feedback and recommendations. All my contact info is below in the description as well. Thank you, YouTube. And this is Mike from The Vital Dose, signing off.